Hey, welcome back to our little series in calculus called Short and Sweet. Today we're taking an inside sneak peek at partial fractions. And by the time we're done with this little bear, it's going to be a great refresher and you're going to be ready to tackle any exam that you've got coming up here in the near future. So, what exactly is a partial fraction? Well, what we're going to try to do here is we're taking a rather complex rational function and we're decomposing it into the sum of two or more simpler rational functions. And back probably in your old algebra 2 days, you got a lot of practice with taking two rational functions, creating a common denominator so that you could combine them and add them together. Now we're going to reverse that process where we break it down into its two simpler parts. For us today, a lot of times you're going to see that this numerator is going to be 1 degree less than your denominator. And for us today, these denominators are going to be distinct linear factors. It is possible to get more complicated and have these quadratic factors or repeated linear factors, but we won't get into that today. Our first fun example, which on the surface has nothing to do with calculus, is just all about decomposing. And then in our second example, we'll show how that's going to help you on your Calc 2 exam. So what we're trying to do is take this more complex one and simplify it into the sum of these two simpler ones. And a lot of times the denominator may not even be factored for us. It may initially be presented to us in this form right here. And that's okay. We would just go ahead and factor this denominator into these pieces right here, and we'll set it up. So an A and B represent a constant. You're always going to have a constant in the numerator if you have a linear factor in the denominator. Now, what I'm going to do here to solve this is I'm going to distribute the LCD through the equation all the way from left to right. Once I distribute that LCD, I'm going to be left with 2x plus 11 equals A times the quantity x plus 3 plus B times the quantity 2x plus 1. Now, what do you do from here? And here's a technique that I really, really like and has made my life a lot easier, is I'm going to pick any value of x that I think is most advantageous. So, for instance, I'm going to let x equal -3. When I do that, now, first of all, the reason that's advantageous is because it's going to make a 0 right here, which is going to wipe out this entire term. So I'm going to go ahead and distribute or substitute that -3 wherever I can, and that's going to make 5 equals 0 plus -5b. And all of a sudden, bang, b equals -1, and I've got my first coefficient. Over here, I'm going to let x equal -1/2 because that would make this quantity right here equal to 0. So substituting that across the board, I'm going to get positive 10 equals just kidding, 5/2 a. And then I multiply both sides by 2/5 to get a 4. So those are the constants that I would substitute in for A and B, and now I've got two simpler rational functions as a substitute for that one bigger one. So how's that going to help you in your Calc 2 class? So here's the integral that's going to show up on your exam, and you're going to say, oh my goodness, where do I even start with this bear? Well, first thing you're going to do is you're going to want to factor that denominator and then go through the decomposing process that we just did on the past slide. Once you finish that, we're going to rewrite the integral. Okay, remember who your A was? I think that was a 4, and that's going to be on top of 2x plus 1. And then your B value is -1. So I'm just going to say -1 over x plus 3. So that's a perfectly legal replacement or substitution for this original integrand. Now, what I'm like, again, this is a very minor step, but I'm just going to rewrite this as two separate integrals. It just feels more manageable to me when I think of it as two small separate pieces. Now, you're probably going to have to go through a u sub where you let u equal this 2x plus 1. You work through all that jazz, and you're going to end up with a coefficient of 2 times the ln of 2x plus 1. Of course, you could derive that term and prove that this is the derivative of this expression, minus the ln of x plus 3. Of course, we'll throw our plus c on there. And if you wanted to get really cute, you could use your log properties to condense everything, where the 2x plus 1 is getting squared. We're going to divide that by x plus 3. We've still got our absolute values, and now you got a really cute answer. But that last step is usually very, very optional. So hopefully this brings back some good memories of partial fractions and you are ready to tackle anything they throw at you.